Hello and welcome everyone. Thank you for joining us for a fun little video that we put together. Normally, we like to talk about high-level threat hunting tactics, techniques, and procedures, commonly known as TTPs, but we're going to switch it up a little and we're going to give you a very specific and technical example of what threat hunting looks like. Before we begin though, if you are interested in learning more about threat hunting, let us know by liking this video and staying tuned for what's next. Have you ever wondered what a keylogger looks like running on a machine or from a log perspective? We have too. And we're going to answer both those questions today. We got our hands on a keylogger that is publicly available to purchase, and we ran it in the Cyborg Sec lab. Not exactly sure what a keylogger is? Well, if this is the first time that you're hearing this term, let us help you out. A keylogger is a specific piece of software that is designed to capture your keystrokes or the keys that you are typing. And they take this information and they save it to a file that's either going to be sent remotely or saved locally so that they could look at it later. The idea is that if you have a keylogger on your machine, someone can see what you are typing. That includes usernames, passwords, bank account numbers, and really any piece of private information you can think of. Cool, right? The first thing we need to do is find a keylogger, which we did. The publicly available Revealer Keylogger from Logicsoft is the software of choice in this case, simply because we Googled keyloggers and we found it. Also, it has a free and pro version. The pro version unlocks a bunch of different capabilities that are locked down in the free version, so we splurged a bit and we got it. Now, before we dive into the lab, let's see what the site has to offer so that we can get an idea of what capabilities it has. Then we can use these to start building some very early hypotheses to help with our hunt. Looking at the site, we see that the Revealer is actually a pretty acclaimed piece of software. First, we can't ignore that it claims to be the world's #1 keylogger, and CNET and Wired support that claim. Also, Softonic says that it has over 6 million downloads, which is a lot of downloads for a keylogger. As we scroll down the rest of the site, it begins to start mentioning its capabilities. 1. It can be used as a conversation recording that captures anything that is typed on the keyboard, including things typed into Chrome incognito mode. 2. It can capture screenshots, so not only does the person doing the monitoring have access to the keys typed, they also have the screenshots to correlate with the keylogs. 3. It offers remote monitoring, so all the files that are saved, whether it be the images or the text files, can be remotely transmitted so that the person that is monitoring doesn't have to risk trying to gain access to your machine over and over again. Finally, it operates what we call invisible mode, which that it is running hidden in the background and never displays messages on the screen. It also doesn't show up in Task Manager or in the list of installed programs. So what can we do with this information? Well, we can start building hypotheses or ideas of what type of activity we're going to look for in our logs. First, let's tackle the idea of file creation. We know that this software is capturing the keystrokes and screenshots, but the question is, where is it saving the data? 2. If it provides remote monitoring, then there has to be some level of network connectivity involved. So we can look for information surrounding that event type and look for the artifacts it leaves behind. 3. How does it operate in invisible mode? We can take some different approaches from here, but let's see what we get. But before we jump into hunting for the keylogger, let's take a look at some of the screenshots of the tool that we ran in our lab. We wanted to run this in our environment for 2 reasons: to confirm some of the claims that the website stated, and to generate the traffic and event logs that we can look at and use to hunt for. First, let's take a look at what the text input capture looks like. As you can see, it not only provides us with the keystrokes that were executed, but at the top, you can see this was all done in PowerShell, so it captures the application. Next, we have the Keylogger Pro collecting screenshots. As you can see, the screenshots support the PowerShell usage and are saved as JPEGs. Here we have the options that you can choose from for remote delivery. We chose FTP, but there are many more options, such as cloud, that you can choose from. We have also set up our target machine, the protocol to be used, and what we want delivered, both the keystrokes and the screenshots. These should be delivered every 30 minutes. Finally, we checked in Task Manager and did not find any indication that the keylogger is running. One note is that we did not use any digital forensics tools or anything out of the norm. We just used Task Manager. So if we used some other special tools, we may have been able to find it. But we were trying to think about what a normal level user would look like. Now that we have confirmed this activity, let's look from a log perspective. And in this case, we'll be using Sysmon, my favorite, as our log source, and we will be using Splunk, which is a security information and event manager. This type of tool allows us to ingest a bunch of logs from many log sources, such as endpoints, servers, network devices, and so on. But it makes hunting for artifacts much easier than the manual way. Our goal here is to test our hypotheses that we have created based on the claims of the tool's capabilities. We are going to do this by applying what we like to call the threat hunting methodology. And in short, what we do is we cast a wide net, basically looking for everything associated with the process. Then we weed out what we don't want to see, false positives or anything that we didn't expect, and focus on one artifact or hypothesis at a time. I know that's not my best description about it, but let my actions speak louder than words, and let me demonstrate this for you. What we've done here is create a query that looks for the revealer keylogger as a general term. Now, the RVLKL value can exist in many different fields. That is why we're using the term operator, which acts like a keyword search. Then, for ease of understanding, we have created some descriptions of what the different event types mean. For example, if you see event code 1, there's also a field that correlates that contains the process create value. Basically, just letting those of you who are unfamiliar with Sysmon know what type of event we're looking at. The query that we crafted is simply looking for the types of events that are generated when the term RVLKL exists in any of the fields. While this is a simple query and doesn't provide a ton of details or artifacts to pivot on, it gives us an idea of the lay of the land. Looking at the results, we see there are network connections being made, files being created, and registry keys being modified, just to name a few. I won't be touching on all of the events seen here, but just providing a little snippet of the activity. Now that we have some results and have started getting answers that support the tool's claims and our hypotheses, we can move like Ross Geller and we are going to select just one event type to see what details we can get and what other answers may exist in the data. What you see here is the query for hypothesis 1. What we've done here is craft a query that will only look at the event code that captures files being created. In this case, event code 11. We're also adding the inclusion statement that image equals star rvlkl.exe star to capture when it is the keylogger creating the files and no other processes. We also added some fields to the stats line in line 3, which allows us to aggregate data and display only the fields that we want to see. Taking a look at the results, we have files being created in the program data directory by our keylogger in both HTML and JPEG formats. So we can safely state that we found where the files are going and where we need to look for where we can look for if we suspect something like this is happening to us. Ironically, we found another file that was created in the results. This is still an HTML file, so we can say we found that activity already, but it is also special because it was created when we were testing the network connectivity and delivery feature that came with it. When we were setting up the delivery method, we could select the test connectivity button, and when we did, this file was created and sent to wherever we wanted, which leads us right up to our next hypothesis, network connectivity. Since we know that this is a feature of the tool, and something that we actually configured ourselves, and we found it in the wide net query, or the first query we ran, we are going to go down this rabbit hole. So this is hypothesis 2's query. Similar to what we did with the file create, we focused on the image containing the value of rblkl.exe, and included event code 3, or Sysmon's event code that deals and captures network connectivity events. We once again modified line 3, the stats line, to only show the fields that we would like to see and are contained in the specific event code. Looking at the results, we now have some more artifacts to pivot off of. In this case, we have a destination IP that we could create a query around. From there, we could look for other processes creating similar activity, or look for other computers exhibiting similar activity. Moving on. We are now focusing on event code 13, or registry key modifications. Registry keys hold information about how your device is configured, and if they are modified or changed, could either harden your device and make it a little more secure, or make it more vulnerable. So anytime registry keys are involved, I like to take a look because I like to understand what is happening. For example, some registry keys hold license information about products, while some can be leveraged for persistence. But let's see what we have here. This is our hypothesis 3 query. Once again, we are focusing on the image containing the value of our keylogger, but change the event code to 13 and modify the stats line to include fields that deal with this event code specifically when it comes to registry keys. Looking at the results, I see one registry key that sticks out, and that is the one at the top of the list. If we look at it, the values BAM stand for Background Activity Monitor and deals with processes that are designed to run in the background. For example, a keylogger. So we have found some evidence that supports our hypotheses and the claims of the capabilities of the tool. You may have one burning question, like I did during this whole process. Shouldn't EDRs or antivirus pick up on this? You're in luck. We actually have a bonus finding for you. The entire time during this, we were focusing on rvlkl.exe, which took our wide net and shrunk it by making it pretty targeted approach. So what we can do is step back again and create a general query to see what other activity exists. Now this is our hypothesis 4 query, and it's the same query that we started with, but now we are adding an added field for more contextual information in the stat line. We can now see that there is another executable that exists or existed, the keylogger setup executable. It is generating some logs for us to dive into as well. So let's look specifically at the registry key modification event. Now the query you see here is what we like to call our mega query. We created it, and as you can see, it has a lot more fields in the stats line or line 3 than usual. And that is because we are looking across multiple event types. So we just want to see the data that exists in the many fields that we have. The one field that sticks out to me and answers a burning question is the reg key field. Here we can see that rvlkl.dll and .exe has been added to the exclusions path as well as the exclusion process, which is again our keylogger. That is how it was been invaded Windows Defender the entire time. Now if you have other solutions, I'm not sure if it will add itself to any exclusions list, but I would love to hear from you if you're able to test it out. And one last gift for you before we leave. I, like the other threat hunters at Cyborg Security, am trying to improve the community and leave it better than I left. So we've created a community level account that you can use to access for free our community hunt packages like this one. It's titled Checking for Windows Defender Exceptions via Registry Events. This hunt package will help you hunt for activity that involves the registry key that controls the Windows Defender exclusions. And here's what it looks like. Looking at this query, we focused on the term exclusion as a keyword, and the registry path field contains Windows Defender exclusion. And taking a look at the results, look what we found again. If you've made it this far, thank you very much for spending your valuable time with us. I hope you learned a lot and find this content helpful. Remember to like this video and stay tuned for more videos like this. I am Lee Arkinall from Cyborg Security. Stay safe, and as always, happy hunting.